Okay, so today we are trying something a little bit different. I've decided to create a video for you to listen to and to watch as you take notes on today's topic, which is, as you can see, fossils and relative time. So what I'm going to do, you should have your notebook open to a clean page on the science side, and I would like for you to take notes as I take notes. So we'll talk about some things that we see here in our slideshow, and then we'll come over here to my document, and I want your notebook to match what you see here on my Google Doc. So let's go ahead and get started. At the top of your notebook page, I want you to write fossils and relative time. Fossils and relative time. That's going to be the title of what we're talking about today. So to begin, we've talked a lot about sedimentary rocks and the sediments that they contain. So this tells us that sedimentary rocks not only contain sediments such as dirt, sand, and pebbles, but they also contain fossils. And fossils are preserved remains of plants or animals. So in your notebook, if you will define fossil as preserved remains of plants or animals. And I want you to write that sedimentary rocks contain sediments such as dirt, sand, and pebbles, but also contain fossils. Okay. So fossils come in many forms. You can see a lot of different pictures of fossils here, animal and plant remains. They can be bones, tracks, plants, or bodies of animals, among other things. And I want you to type that in here next. Fossils can come in many forms, such as bones, tracks, plants, or bodies of animals. So fossils and relative time. This tells us that rocks of the same age contain the same or very similar fossils. So you can look at two different fossils and kind of be able to tell how old they are and if they're similar in age or if one is older than the other. So for example, recently formed rocks may have a lot of these fossils. Here we have a starfish and what looks like a leaf. And then rocks from older time periods may contain a fossil of something that we're not very familiar with. And then you've got rocks from an even older time period that may not contain the fossils found in previous examples, but may contain these types of fossils. So basically, depending on the age of the rock, you're going to have fossils from different time periods. So I want you to add that into your notes. All right. Now going on down, it tells us when the same kinds of fossils are found in rocks in different places, for example, fossils of an organism that no longer exists, we know that the rocks are the same age. So I know a lot of you are very interested in dinosaurs. So dinosaurs existed many, many, many years ago and do not exist any longer. So if a scientist were to look deep, deep, deep down into the rock, into a layer of rock that existed many, many years ago and found fossils of dinosaurs, they would be able to tell that that rock is X amount of years old. So this picture tells us if fossils of this organism are found in these three places, then the rocks they were found in are all the same age. So what I want you to type here is that when fossils when the same kinds of fossils are found in rocks in different places, we know that the rocks are the same age. Now, here we have fossils in relative time. So this means that the age of a rock can be determined by the fossils that are found in it. I want you to write that down. The age of a rock can be determined by the fossils that are found in it. A rock can also be compared to other rocks by the fossils the rocks contain. Comparing the types of fossils in the rocks will show which rock is older than the other. We're going to add that to our notes as well. So when we compare fossils, we can form a general timeline of organisms that existed throughout history. So these are images of fossils from very, very long ago. And as we go up to more recent times, we can see fossils of organisms or plants that are more recent. And again, the fossils found in that rock kind of tells us how old the rock is. So the kinds of fossils found in rocks from different time periods change because animals and plants also change through time. They're not always staying the same. So these patterns of fossils exist all over the world, but in certain places, fossils are also found in different rock layers because the environment of that particular place changed throughout history. So you can see here in these pictures, at one time, this area of land was filled with water, and then over time, it gradually became more of like a desert and dried out. So obviously, when this picture was taken, we can see a lot of water, and we know that organisms such as fish and other types of organisms that live in water would survive in this environment. But as time passes and the water begins to decrease, they're not going to be able to live in an area such as this. And this is where you're going to be able to see some fossils of those water organisms who no longer are able to survive in that environment. And it gives us an example here of fish and shell fossils. So this question asks us, what do you think scientists would be able to tell happened in that place based on what they learned from the fossils? So here in your notebook, I want you to ask yourself that question. So write this down with me. Question: what do you think scientists would be able to tell happened in that place based on what they learned from the fossils? And you are looking at these pictures from these two slides to kind of help you answer this question. So once you've answered that, we can move on. So finally, fossils can tell us many things about the history of one place, one region, or the entire planet. And that's all for today.